So let us talk about stream processing in a bit more details. So I have prepared a diagram where you can see four components. So we have collect, process, store, and then visualize. So let's say we have some client applications, and they are sending data to continuously to some kind of systems like Kafka. Now the first step is collect. So in any stream processing pipeline, you will see like mostly these four high level steps. First of all, you need to collect the streaming data, and for that we need some kind of a streaming platform. So Kafka is a very widely used streaming platform, and it's also called PubSub. So let's say our client applications can send events to the Kafka, and Kafka can store it. Now we need a processing engine, right? So we can use any kind of processing engine like Spark or Flink to process our real-time data. So whatever events are getting generated from the client applications are being collected in the Kafka topics, and then our processing engine can read from the Kafka topics, process it, and then send the results to the sink. Now it can be cloud storage like Azure Blob, AWS S3, or it can be time series database like M3 DB. So if you are doing a time series analysis, then the results will be stored in the time series database. Now if you're doing some kind of simple ETL, you can also say continuous ETL, where you are continuously reading the data from Kafka, doing some processing, and storing the data into some cloud storage. It's called a continuous ETL, where you're not doing a lot of analysis but rather storing it into some kind of a sink. And for time series analysis, you can understand like let's say you want to analyze customer behavior, and you want to uh, calculate the unique visitors on a web page between 10 and 10:15. So that is kind of a time series data where you will be generating the time series and pushing that to the time series database, and then using the Prometheus or Grafana. Here I have mentioned Grafana, so you can visualize those time series database. So we have Prometheus query language, we also call this PromQL. And so what you can do is write PromQL and fetch the results from the time series database and plot it into the Grafana dashboards to visualize the real-time data. So overall, in any organization, the stream processing pipeline generally will have these four stages. It can have more, but on a high level, these are the basic four steps that you will see mostly in any organization. Now let's talk about some of the stream processing use cases. As I already discussed, like the first one, which is real-time data movement. As I already discussed, continuous ETL. So where you capture the data, process it, and store it somewhere. And now there is a real-time analytics where we are doing some kind of analytics on top of the data. So we have log analysis, we have clickstream analysis, and then we have real-time updates and IoT. So there will be more use cases, but it's better that we focus on some specific use cases and try to understand with an example. So let's I'll talk about log analysis and clickstream analysis. Real-time updates like gaming and trading, you can already understand. It's like, let's say you are in a gaming session where the real-time updates are happening, and it's a multiplayer game. So the updates need to be in real time, obviously. Similarly, in IoT use cases, you need to have a real-time monitoring systems for the patients. And for retails, you can imagine like for Walmart or Amazon, they will have to build some recommendation systems, so they will have to implement real-time processing systems so that they can be ahead of the game from their competitors. So I have taken one example for the log analysis. And let's say this is one event this is another event, this is another event. Now let's say all of these events are coming to Kafka topic one by one, and your processing engine, let's say you're writing something in Spark, and you have to analyze a few things, like let's say unique IP is between the 14 and 15 hours on 4th Jan 2003. So as I already discussed in the last video, that we will have aggregations, but those will be windowed aggregations, so always the timestamp will be there. So that's why I have mentioned like between 14 to 15 hours, because the data is unbounded, so we'll have to do windowed aggregation. So if you want to do log analysis, so this is an example of log. Let's say you want to also analyze like how many get calls are coming. So first one is IP, then you have timestamp, then you have the HTTP get put whatever can come here, then you have the resource, the web resource that is being accessed, and then you have HTTP protocol, and then you have response code. I believe this is the response code. So you want to analyze a number of get calls between 14 and 5 hours, let's say between the 5 minutes of window. So that you can do via Apache Spark and the Kafka combination. So this is an example of log analysis. Let's discuss about the clickstream analysis as well. So what exactly is clickstream analysis? So the definition, by if you go by the definition, the process of tracking, collecting and analyzing the sequence of actions. So what it is exactly, let's say you are you are browsing an e-commerce website like Amazon or Walmart. So what they will do is they will track your clicks. They will track your clicks, they will collect your clicks, and they will try to analyze like what are you trying to perform on their website. All right, so I will show an example to you. So this is the walmart.com website. As you can see, I have opened here, and let's say we are doing something. Let's say I am hovering over the items, and let's say I clicked on this. So as you can see, if I click on this, there are a lot of events that are getting fired in the background. So a lot of API calls will be there, and obviously whatever you clicked, they know what you have clicked. All right, and let's say I'll just clear this and I'll click add to cart. So if I click add to cart, which means another set of events got fired, and then they know that I have added the items to the cart. And now let's say I go to the cart again, I will click it, and then I'll try to remove it. Now again some actions, as you can see, a lot of events are getting fired. So what I'm trying to say is, in the clickstream analysis, whatever clicks you are doing, those are getting captured, and along, so there are a lot of other informations as well in the clickstream example. For example, let's go back to our example here. So a clickstream analysis, you can have this kind of fields here. So let's forget about the auction and the campaign. Minimum things that will be there will be, let's say, the device ID. So this is the device ID, let's say, and let's say I'm browsing through my laptop, so it will have some device ID. If I am browsing through my mobile, it will have a different device ID. And this is the event time. So event time is the timestamp that is embedded in the data itself, and this is very much important to understand. I will be talking more about the event time and the processing time in the coming videos. So event type can be, let's say, click or impression. Click means, impression means, let's say I have visited the page, that's an impression. And if I have clicked something, that is called as a click. So let's say they want to analyze like total clicks between timestamp 1 and timestamp 2, so they can do it via the clickstream analysis. So there are other things like find all the unique IP counts between T1 and T2, then find all the unique devices between T1 and T2. So all of the analysis, clickstream analysis, can be done via Apache Spark streaming with the help of obviously Kafka So going forward in the coming videos, I'll be showing examples of how we can actually do Spark streaming with Kafka. So I will suggest that do stay tuned and watch out for my next videos. So as I already discussed with you, I am again iterating because I want you to understand very clearly like what exactly is clickstream analysis, because it will lay the foundation for you to understand the stream processing. So the clickstream analysis. So let's say we, while browsing an e-commerce website, we added a few items to the cart, all right, and then also remove those. Okay, so now the organizations can tell like what you added some items to the cart but you did not complete the purchase. Okay, so now what they can do is they can recommend you something like let's just see which is similar to that which you added and removed, and which may be cheaper or even better or even trending, so you might be tempted to buy that. So you can either leave the site or you may be tempted to buy those after seeing the recommendations, right? So why do organizations are doing this? So that they can stay ahead of their competition, right? They to attract more customers, to generate more revenue, all right? So that is what they are trying to do. So they are trying to stay ahead of their competitors, all right? So I hope I was able to make this example clear to you, because this is very much important. And hopefully in the coming videos you will see when you see a real example with the actual data and the Spark streaming code example, you will understand a lot better. All right, so stay tuned. Thank you so much for watching this video.